is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I would like to discuss about stress concentration. This stress concentration is a very important criteria in design of machine elements. So, in this session, we will see the definition of stress concentration and what are the reducing methods of stress concentration. We will see. Stress concentration means whenever a mission component or the mission component or part changes its shape of its cross section. So that means it suddenly changes its shape. So suppose example from uniform cross section to some other cross section, some irregular cross section, clear, or any other squared cross section. So then whenever it changes its shape or cross section, then the simple stress distribution lines are some disturbed. So it means the stress distribution is no longer holds good. Clear. So suppose in the uniform cross section the stress lines are flowing uniformly. Whenever the changes its shape, the suddenly it's the disturbed, that lines, the flow stress carrying lines will disturb. Clear. And the neighborhood of the discontinuity is different. So this regularity is in the stress concentration distribution caused by abrupt changes of form is called stress concentration. So there more stress will concentrate. So that is the basic definition of the stress concentration. Clear. The stress concentration means is a location in an object where stress is concentrated. Already we have discussed. An object strongest when force is evenly distributed over its area. So a reduction in area, so example caused by a crack or results in localized increase in stress. Due to this, suddenly it may changes its area. Clear. So it occurs for all kinds of stresses in the presence of fillets and notches and holes and keyways, clear, splines and surface roughness or scratches, etc. So due to all these the extra things, the stress concentration will be more in the component. So at that time, so how to reduce the stress concentration? So otherwise the component it may be damaged or it will fail after some time. So that's why you're designing the stress, any component, the stress concentration is how to take as main criteria. So see, in this diagram I shown this stress distributed lines. Clear. Here taken some component, it is subjected to tensile force. Clear. So it is subjected to tensile force. So the example some 20 kilonewtons. Clear. So it is having some hole. So this is called as discontinuity. Clear. Suppose the cross section is like this. Whenever this component is subjected to tensile force, clear, the distribution, the stress distribution lines, these lines are called stress distribution lines or force carrying lines, are in a uniform. So it means the lines are occupied in a uniform space, uniformly arranged. Clear. So in this, there is no stress concentration. Clear. But in this case, whenever the object is subjected to tensile force, see here up to here, this the lines uniform line, and there is no disturbance. But here see, whenever discontinuity is present, in this case the flow lines are disturbed. Clear. So here the force carrying capacity is less than the remaining lines. So at which at this region the stress will be more. So the concentrate, the more stress will be concentrated. So this this phenomenon is called as stress concentration. Okay? How to reduce? So how to minimize the stress concentration? We will see in next slides. The theoretical or that form stress concentration factor is defined to calculate the localized stresses, clear, as the ratio of the maximum stress in a member or a notch or fillet to the nominal stress. This is the stress concentration factor. It is represented by the KT, theoretical stress concentration factor. So it is the ratio of maximum stress to the nominal stress. So nominal stress you can calculate directly by using empirical relations. So and then the maximum stress you have to calculate by using this theoretical stress concentration factor. So that's why in this stress concentration theory, actually in this it is based on flow analogy theory. So generally, for calculating any tensile stress or compressive stress or shear stress, we are using relations. So that is load for area. So the tensile, if it is subjected to tensile load, the tensile stress we can calculate by using tensile load by area, cross-sectional area. But those equations are derived on some assumptions only. But we can always you can calculate those stresses whenever the object is in uniform condition, or otherwise have to assume always the component should be uniform. But in this irregular components, or whenever holes or notches or fillets presented in the component, we can't calculate the nominal stress directly. So clear. So why? Because there is some discontinuity. Clear. So by using this theoretical stress concentration factor, we can calculate the localized stresses where the maximum stress will occupy that particular region. So that is calculated by using this theoretical stress concentration factor. So clear. This KT depends upon the material and geometry of the material, geometry of the component. See, another one is fatigue stress concentration factor. So when a machine member is subjected to cyclic loads, so whenever the component is subjected to repeated loads, clear, there the fatigue failure will occur. So this value of fatigue stress concentration factor shall be applied instead of theoretical stress concentration factor. See, so the KF indicated here fatigue stress concentration factor. So in the fatigue stress concentration factor, we can calculate by using this relation endurance limit without stress concentration, or upon the endurance limit with the stress concentration the factor. Clear. So what is the endurance limit? We will see in the next session. So next, the notch sensitivity. So it may be defined as the degree of the sensitivity. So that is which the theoretical effect of stress concentration is actually reached. Suppose any object or subjected to load, so then stress concentration occurred. So we are considering the stress concentration while designing. So there, so you have to measure the notch sensitivity. The sensitivity means the sensitivity of the component. Clear. So that's the degree. So in other words, the magnitude of the stress concentration. Clear. The notch sensitivity factor Q is defined as the ratio of increase the actual stress to the increase in the nominal stress near the discontinuity in the specimen. Clear? So we can calculate the Q, the notch sensitivity, by using this formula. Q is equal to KT to KF minus 1. Clear. So the stress gradient depends mainly on the radius of the notch, hole or fillet, and then the grain size of the material. So the methods to reduce stress concentration, the presence of stress concentration cannot be totally eliminated, but it may be reduced to some extent. Clear? So we can't eliminate the stress concentration completely, but somewhat extent we can reduce. What are the reducing methods we will discuss? So a device or concept that is useful in assisting a design engineer to visualize the presence of stress concentration. So how it mitigated to is that of stress flow lines. Clear? So mainly it depends upon the stress concentration phenomenon of flow, and we can measure by using flow analogy theory. See here shown some figures from A to D. The first is a figure. See here it indicates 4. So and it is good and preferred. Why it is mentioned like this? So in this C, it is whenever this object is subjected to load, tensile load, the stress distribution lines are force carrying lines. So you can observe here, in figure A, clear, lines tends to bunch up and cut very close to the sharp. Clear? So in order to improve the situation, fillets may be provided. Okay? So at here very near to this sharp edge. Clear? So in this case, the stress concentration, the stress will be concentrated at this portion will be high. So you have to reduce the stress concentration at this region. So the reducing methods here provide some fillet. So here fillets provided. So here somewhat reduced here the stress concentration. So you can observe in this the diagram. So here the stress distribution lines are not very near to this sharp edge. Clear? So the bent like this. Clear? So similarly, so in the other case C diagram, this one is preferred. So here the long the fillets are arranged here, and this one is better than this C. Why? Because this long fillets in practically not in use. Clear? So that's why some notches created in the component. Okay? So due to this the method, providing notches, providing fillets, we can reduce the stress concentration of a machine component. See, here the following figures so the several ways of reducing the stress concentration in shaft. Clear? So and other cylindrical members with the shoulders and holes and threads. Here first one is the 4 and the second condition is good and preferred. See here whenever subjected to the movement, so clear here the stress distribution lines are like this in the first figure. Here very near to this edge. Even though the fillet is there. Clear? Here second case is so somewhat better. Why? Because here provided one notch. Okay. Here this one is the long here large of the fillets are provided, so that's why this one is preferred. So away from this line, see very near to this the sharp edge and this fillet edge, and is somewhat reduced, but here they completely away from this edge. So that's why there is no disturbance in the force carrying lines or test distribution lines. The main the aim of reducing the stress concentration is to reduce the flow line area or the equally reduce the space between these two stress distribution lines or force carrying lines. Okay? Otherwise, the reduce the minimize the flow bent line. Clear? Here flow bent line. Suppose in this component example, here stress distribution lines are like this. Clear? So you have to reduce here the bend of this line. So what will you do? You provide some fillet. So due to this fillet, the stress distribution line will bend like this. So this is preferred. So some other figures shown in this slide. So see here shaft subjected to the tensile load and having the wall also, and this is very poor. Why? Because the stress distribution lines very near to this discontinuity. So it means wherever the wall is present, there more stress will occur. So this one is preferred. Why? Because provided some other one more hole. Okay, by drilling more holes also we can reduce the stress concentration. And in a shoulder in a threaded portion here very poor, and this somewhat better, and this one is preferred. This is in a uniform taste. Clear? So this is not in uniform, somewhat better, and the preferred one is this the flow line not in a bent condition. Clear? So like this, we can reduce the stress concentration in a machine component to avoid failures. Thank you. These are the references.
Like, share and subscribe. Hit the bell icon for more updates.